All right, Hope, birthday girl. We're on 6-2, rational exponents and radical expressions. All right, so the reason why this is all grouped together is exponents so far have been strictly like whole numbers and negative numbers. They haven't been fractions. And when you have a fraction, what that gives you is a radical. Okay, have you guys ever heard of square root before? Yeah. Okay, so squaring and square root, they undo each other. Cubing and cube root, they undo each other. All right. So what that is basically we just have a fractional exponent. So what I want you guys to kind of pay attention to over here is this little box. Okay. If you have a number to a fractional exponent, what that means is it means you're going to have a square root, but the way I kind of envision it is if I put my thumb on n on my like right hand and my pointer finger on m, it kind of falls over. So then I have the nth root of a to the m. Do you guys kind of see that, how it like falls over? All right, so that's how I kind of think of this. All right, so examples of it would be x to the 1/2. This would be the square root of x. But notice I don't have a number outside of that. It's implying that it's going to be the square root, which is like a 2. All right, 9 to the 1/2 would be the square root of 9. Okay, and that's 3. And then x to the 2/3, that's the cube root of x squared. Do you guys understand like how that works a little bit? Now, what does all this mean? Okay, and the way I think of it is this. This number outside the square root, that little number, okay? So for example, in C, that 3 is talking about how many pairs of that number do I need in order to pull it out, okay? So let's first talk about how to write an expression from something with a rational exponent to radical form. All right, so x to the 2/5, okay, I kind of have this house, and then I think of it this way. X is in the house, but now the kind of little numbers, if I put my fingers on the 5 and the 2 and they fall over, the 5 goes outside the house. So that would be the 5th root of x squared. And then b, this is a to the 7/4. Okay, so I have my little house here. A is in the house because that's my base. And then if the fraction falls over, I have the 4th root of a to the 7. You guys okay with that? All right. Now, this is what I was talking about with pairs of numbers here. Okay. All of these right here, all of these examples, zoom in so we can see it. The number outside that square root is a 2. So I'm looking for pairs of numbers. Now, do you guys remember back in the day, Kevin, the old school prime factorization tree? Do you remember that? You sure? Are you lying to me? All right, I'll take your word for it. Only because it's So's birthday, and nobody lies on So's birthday. Okay, so this is how I do these problems, and teachers do it different ways, and I just found this is like the best way for me. Okay, Kevin, give me 2 numbers that go into 48. I don't care what they are. 24 and 2. So the way I do it is I make my tree and I do 24 and 2. Okay. Now I'm no longer dealing with 48 because I have like 2 legs coming off of it, right? Now, can you break down 2 into like smaller numbers? 1 and 2, right? Because remember, it's got to be multiplication. Now, if I break down 2, I get 1 and 2. Do you see like the repetitive loop there? of like, we're only gonna have like twos. So this is a prime number. I can't break it down any further. That's why I was going back to like, do you remember the prime factorization tree? Okay. Once we break it down to a prime number, that number is kind of done because I can't break it down any further. But Kevin, 24 we can break down, right? Two numbers that go into 24. Well, does 12 times 6 give me 24? No. So it's going to multiply to give me 24. 6 and 4. So I'm no longer talking about 24, I'm talking about 6 and 4. Notice, all right, here, notice if we do 6 times 4, we got 24 times 2. We're still talking about 48 here, even though it's smaller and different numbers. Now, do you have any pairs of numbers yet, Kevin?
3 and 2.
Well, do we have any pairs? You're one step ahead of me. Are any of these the same number? The 6, 4, and 2? No. Now let's break down 6. And
2.
2. Do you see a pair of numbers?
2 and 2.
2 and 2. So I circle them. All right, we're not done yet. Still working, okay? Can't break down 3, right? It's a prime number. 4. Can you break down 4? And 2 times what? Gives me 4. 2 times 2. Do you see a pair of numbers? Now, the square root of 48 is going to be equal to, okay? I have my house, okay? It's going to be equal to this. Everything that had a pair, notice I had a pair of 2s, right? Over here. Does everybody see that? That 2 comes outside the house. Times, do you see this second pair of 2s here? Kevin, you see that second pair of 2s right there? That comes outside the house. Okay. See how this is going to be today. And do you see this 3? Do you see how it didn't have a friend, so to say? That goes inside the house. Are you okay with that?
Yeah.
What's 2 times 2? So the square root of 48 is equal to 4 root 3. Now, do you guys have a calculator or that Calculate 84 app? All right, get it out. Because this is how you're going to check it on like the keystone. All right. Now, on the keystone, they are going to give you multiple choice. They're going to have like A, B, C, and D. Okay, Kevin, do you have a phone? Are you allowed to download the Calculate 84 app? Okay. So what I want you to do is I want everybody to type in the square root of 48. And the square root of 48 is going to be like 6.9. Okay. Tell me what you get when you do the square root of 48. Do you not know where the button is? Blue button. And then see the X squared button. All right. So I have fat fingers, so you're gonna have to exit out. Type in 48. Hit enter. You see how you have 6.9? Okay, now type in 4 root 3. Root. Yeah, that square root button. 3. You see how you got the same number?
Yeah.
Okay. Did everybody see that? Was everybody able to get the same number? Me? Okay. So when you're doing this on the keystone, all right, what you'll do is when it says like, oh, break down this square root, the square root of 48. Andrew, what you're going to do is you're just going to type in the square root of 48 on your calculator. You're going to get a decimal. Then you're going to type in each of the answers, Delaney, and you're going to see which one matches up decimal wise. Make sense? If it's open-ended, well, then we have to do this. Okay. Are you guys all right with that? Drew, you okay with that? All right. Now, before I go too far, all right, Kevin, Ready for this? I just want to talk about this. We know the answer is 4√3, okay? And there's a lot of different ways to do this. Kevin did it one way, all right? I'm going to kind of do it a different way. Now, remember, I said it's all about pairs of numbers, right? So Kevin had to keep breaking it down because he got, like, he didn't have pairs. He had to break it down until he got pairs of 2s, right? Now, when I look at 48, I think of 16 and 3. Now, why do I think of 16, 3? Well, you'll see in a second, okay? And then I don't have a pair, can't break down 3, so let me break down 16. What times what gives me 16? Think about it. What? 4 and 4. Now, why would I want to break down 16 to 4 and 4? Because it's all about pairs of numbers. I could have broken 16 down to 8 and 2, but notice that doesn't give me a pair of numbers, does it? Do you see a pair of numbers up here now, Kevin? So I circle it. Can't break that down any further. That comes outside. Do you see how I quickly get to 4√3? So it's all about finding those pairs of numbers. It doesn't matter what pair of number, all right? We're just looking for pairs, okay? All right, I want you guys to try and break down the square root of 8 and then check your answer using the Calculate 84 app. All right, see if you got it right. A lot of people do this by so if they like C16, great. Otherwise, keep on going.
Yeah.
Hope you're getting a lot of birthday texts. Is she telling you happy birthday? There you go. So, love how you're. I think if you download it, it's probably going to be better. But if you have a graphing calculator, that's ideal. All right, so let's look at 8. Now, when I look at 8, okay, immediately comes to my head is 4 and 2, right? It's the only way to break down 8. And then 4 is 2 and 2. So there's my pair of 2s. Then we get 2√2. Did everybody get 2√2? Okay. All right, Liam. What numbers go into 18? What did you say? 9 and 2. I'm glad you said 9 and 2. You could have said 6 and 3, right? But 9 and 2 will allow you to get the answer a little quicker, right? What goes into 9? 3 and 3. There's your pair of 3s. Circle it. My answer is 3√2. All right, Emma.
Yeah.
32. Two numbers that go into 32.
8 and 4.
4. Awesome. Now, let's break down 8. Emma, two numbers that go into 8.
2 and 4.
2 and 4. Well, that works well for me. Emma, do you see a pair of numbers?
Yeah.
Yeah, 4. Okay. So I can circle them. I can pull it out. So my answer would be 4√2. How do you guys feel about that? Not bad? You guys think you can handle it on your own? All right, we're gonna try one on your own. I'm gonna give you a big number, and I don't even know the answer to it. Okay, so off to the side, let's write this one. Ready? Delaney, what's your hockey number? 7? Do you play hockey? What's your lacrosse number? 7-11. You're joking, right? Wow. I don't think I can use that.
Just use someone's like.
Oh, Hope, what's your birthday?
What number are you looking
I don't know.
Birthday date. What about 16?
Very-
Do 16.
No, all right, here we go. I don't want to do 16. Let's do. When's the last day of school?
The 18th.
All right. 618. I don't know. See if you can break down 618. I don't know the answer. Okay. You have 618. I want to know the square root of it. Could get an answer, might not get an answer. I don't know. See what you can break down. See where it goes. Okay. You're looking for two numbers that go into it. 7.
And 1.
1, 13. Nobody has like an even birthday.
Your birthday.
January.
You finished at 15.
15 will help you.
I don't think this
Hi.
works.
What? Okay. Try it.
It's like that.
Okay. All right. Let's see where. Neve,
So I separated it into 309 and 2.
2 and 309.
Then you separate 309 into 3 and 1 and 3, then it can't be divided anymore.
How do you know 103 can't be broken down?
Because we aren't using investments, are we?
Well, how do you know? Did you try all the numbers?
I did it in my head and I know 1 and 3.
Oh, okay. So the way I think of it is what, like 10 times 10 gives me 100. It's like close enough. So if I check all the numbers like less than 11, right? Does 11 go into 103? No, because 11 times 9 is 99. 10 doesn't go into it. Okay. And then I'm like, does 9 go into it? No, because 9 times 11 is 99. 8 doesn't go into it because it's not even. 7, well, maybe, right? So 7 goes into 10
It would.
one time, and then we're left with 33. 7 doesn't go into 33, so that doesn't work. Don't have to check 6 because that's not even. Okay, 5 doesn't go into it because 5 doesn't go into 3. 4, it's not even. 3 doesn't go into it because 1 plus 3 is 4. Okay, so we're done. All right, so they're not all going to break down. Hopefully, I was hoping it did, but it didn't. It is what it is. All right, can't win them all. All right, but do you guys see how to do it and see how to break it down? You're looking for pairs. Nate, you okay with that? Drew, you okay with that? No, we don't have to. We'll get plenty of. All right. All right. All right. This is a little bit trickier. So it says to simplify a cube root, use the same process as a square root, except we're looking for 3 of the same number. Now, how do I know I'm looking for 3? See the 3 outside? See the 3? So I'm looking for 3 of the same number. Now, we're going to start with 125, and then we're going to go to 54, and then we're going to go back to that middle one. All right, still same process. Hope, two numbers that go into 125. Are you thinking too hard, Hope? You remember back in like 5th grade, the division like rules? Do you remember that? So, all right, here's some division rules. All right, you heard some. Okay, ready? Here's some for you, Hope. If a number's even, 2 has to go into it, right? You know that. Now, 3, how can I tell if a number is divisible by 3? Well, it's simple. You add up the digits. So I do 1 plus 2, that's 3, plus 5 is 8. Is 8 divisible by 3? No. So 125 is not divisible by 3. Now 4 has a tricky rule, okay? 4 is the last 2 digits. Is that divisible by 4? 25? No. But I like to think of it this way, even before that. Mr. Ferry, you're dozing off a little bit. You were going to slide out of the chair. You got this. All right, so I like to think of, okay, before I even think of the last 2 digits, this is what goes through my head. 125 is not even. How can 4 go into it? You know what I mean? So like, it has to be even in order for 4 to go into it. Now 5 will go into anything, Hope, that ends in a 5 or a 0. Okay? 6 is anything that's divisible by 2 and 3. 7, there is no rule. 8's very similar to 4. I'm not going over it. Okay. 9, well, 9's like the same thing as 3, right? You have to add up all the digits and see that if that's divisible by 9. And 10, it has to end in 0. And that gets you through a bunch of this. So Hope here, what goes into 125? 5. So we do 125 divided by 5. And that gives me 25. So Hope, what goes into 25? 5. So that's 5 and 5. Now, does everybody see how I needed 3 5s? Do you see how I have 3 5s? So I circle them. So my cube root of 125 is just simply 5 because there's nothing left. All right. Sophia, let's look at the cube root of 54. We're going to come back to that. 2 numbers that go into 54. Well, 2, okay, as soon as you decide 2, to get the other number, you're going to do 54 divided by 2. That's going to give you this number. All right, so you have your calculator, right? It is 27. So remember, 2 and 6 would give me, 2 and 6 do go into 54, but it has to be 2 times that number, okay? Now we have 27, right? We know we can't break down 2. Can we break down 27? And the answer is what, Sophia? Think about it. No? Sophia's got it. 9. So 9 times 3. And then it's easy to see 9 is 3 and 3, right? Now, do you have a group of 3? Yeah, we actually have one group of 3. All right, so the number of like circles of the number is kind of like the number of times I pull it out. Remember in the first problem we did today, I had like 2 groups of 2 and I pulled out 2 2s, right? Here I have one group of 3, so I'm just going to pull that out. So it's going to be 3 cube root of 2. All right. You okay with that, Delaney? I know it's almost over. Class is almost over. I know. I'm excited too, because it means I only have like 7 more periods to go.
How do you not forget the 2 and leave it hanging?
Because I'm a math teacher. I don't know how else to tell you. Gotta be methodical. Gotta remember everything. That's why I kind of like cross out the numbers so I can easily see the numbers that are left. But to answer your question, it's just because I'm a math teacher. When I was a math student, I forgot numbers all the time. But then as soon as I became a teacher,
Boom.
boom, that's what it was.
Get your degree in the
Yeah, you just get it. Makes sense to me. All right, now. So if you ready for this one?
Yeah.
Okay. Now, are you scared of the problem? Oh, that's good. That's good. I'm not afraid of it either. Okay. So here's the thing. We have some variables there, right? Any ideas what to do with the variables? Well, what's my one rule? When in doubt, write it out. All right, so let's write this out. So I'm looking for groups of 3, all right? Don't mess with the 32 yet, okay? What? Write it out first and you'll see, okay?
3 on the outside.
Ready? X's. How many X's do I have? 1, 2, 3, 4. How many Y's? 1, 2, 3, 4, 5. First off, do you see any, groups of 3? Right here, right? See the 3 X's? See the 3 Y's? See that? So when I'm trying to break this down, I have my house, okay? We're talking about the cube root here. An X came out, right? I had one group of 3 for the X's, right? I had one group of Y's that came out. Now, what's left inside was 1 X and 2 Y's. You see that?
Yeah.
Now, here's an easy way to do it. Ready? I don't like writing it out. How many times does 3 go into 4? So I pulled out 1 X. How much is left over? 1. So it's what's left inside. How many times does 3 go into 5? So I pulled out 1 Y. How many was left over? That's why there was 2 left. So I divide, okay? Now, let's break down 32. Give me 2 numbers that go into 32. Two numbers that go into 16. 4 and 4. You could do 8 and 2. There's your pair of 4. Ooh, no, not doing pairs. We're doing 3s. So we're going to do 4 and 4. 2 and 2, 2 and 2. All right, now I need a group of 3, right? There it is. That 2 comes out. What's left? 2 times 2, which is, so I put a 4 in there. All right. Any questions on that? No questions? No? All right. I'm going to stop there.